Okay, so we talked about the databases, but what are the entries? How does the database look like? Because up to now, we've organized the whole system. I showed you the hierarchies, the trees, and how all this is put together. And then I said, okay, and this is all stored in resource records. These are the elements stored in the databases. So what is a resource record? A resource record is a simple tuple. There's a name. Well, I will give you several examples for a name. Here you see a simple one. So it's a web server of Google. So it's a name. These are all fully qualified names in this case. There are other cases. So that's the name. And then it tells you how long is this entry valid. A time to live, seconds. So 86,400 would be then a whole day, etc. So that's a time to live. Because those entries also outdate. Why? Well, this has something to do with how to achieve at least a kind of a weak consistency across all these databases. If you change something, this change will not immediately propagate through the system, but the entries will time out. And after the timeout, in the worst case, you have to go back via the root, etc., to get the authoritative answer from the master, the primary master of a zone, for example, if no one else knows anything. So, all the entries have a time to live, up to a day, for example. And this also gives you impression why it takes a while before updates really propagate through the whole system. Because there might be entries still there in the database that are outdated. But there was still no, well, TTL 0, that means the database did not delete this entry. I'll come back to this. Then we have the class. This is kind of boring because almost all entries have internet as a class. There are some others like chaos, CS, etc., but rarely / never used. So yeah, we have a lot of legacy in those systems. Then, quite interesting, we have many different types of entries. I will come back to this, show you a table. And then the value. So what does it mean? In the end, this entry means that the www.l.google.com computer has this address. So A stands for address. So that's one of the entries, and this is also a must-have, that we know the IP address of this server. So that's an address entry. This is what the A stands for. And then in your zone file, that was the name for the file in the database, you have a lot more entries. And this is an example where you see, okay, here we have the address, for example. We have addresses for computers. You have the lifetime for a day. It's all internet. And you see, oh, there are many more types. So we learned a bit about addresses. Yeah, great. So address, this is what you know now, that computers need at least IP addresses. You see this, and many more entries. Like, for example, MX, mail exchanger. I will come back to this. Or CNAMEs. So that's an entry that tells us that, okay, to the outside world, we see this is an alias. That's the web server name. But in reality, that's the name of the computer. So you see, that was the mechanism of how we can then say, maybe next week, oh, let's replace this computer star. Maybe now it's Mars. So we enter the entry here. We do not change the name of our web server, only because we changed the computer. So you have many entries here, and at the end you can insert a lot of text here, etc., etc. tell everybody who's responsible as a mail server and so on. So, what do we have besides all this? There can be many more things, but the most interesting entries, and that's the must-have, is the address. So that's, we have to say, okay, that's the address for a certain host. That's quite important. That's for IP version 4. Here we have the address for IP version 6. Then, quite important, we have mail exchanger. Then, for example, if you want to know who's responsible for email for a certain domain, and then this has to refer to a computer, so this mail server, and then this will be mapped to an address. So because the mail server again is a name, and then this is then in the end mapped to a real address. We saw we have these CNAMEs, so pointers to the true name, so references then, etc., and some more. And then we have an interesting entry that is not a must-have. That's the pointer entry. I will come back to this also. That is needed for the reverse lookup of a computer in the DNS system. And then there are many more. So just to give some examples of the, I would say, most important ones. Well, you have to know, for example, who's the name server. So for a certain domain, you have to know who's responsible. So this is where we need the NS records. So for movie, edu, we have the entry, yes, whatever, the terminator. But also we have another wormhole. Could be several. So we have 2 name servers in this example installed on terminator and wormhole. That's possible. Now, if you want to know the name server, okay, that's fine. I know it's terminator and wormhole. So, but how to reach the computers? This is why I need more entries. This is all in this database. That now I learn that, okay, terminator, if I contact this, okay, that's the IP address. That's just an example. So I need this entry because otherwise how to find the computer? So each host needs at least one of these so-called A records. So that's needed. Otherwise I don't know the address. There are also some more advanced concepts like multi-homed hosts. So you see, okay, it has 2 IP addresses. Okay, so that's the idea, that you map certain functionality, name server on names, and the names then on IP addresses. There are some more optional entries like canonical names, the CNAMEs, and you say, okay, whatever this name, big T, whatever, that is basically a pointer to the real computer, terminator, but terminator has then this address. So you need several lookups then in the end, the database, to find out the IP address. Okay, that's the idea. And then we have these multi-home computers where you have A records for every secondary name, etc. So look it up, not only Wikipedia, also in the standards. You see there are so many more entries possible here. So you can use DNS for many purposes. That's just the very basic, the must-haves, like the A records, because I have to know the names and mapping to the addresses, and the NS, I have to know the name servers. And then just to make it a bit more complete, we're talking about reverse lookups, and this is where we need these pointer entries, and these entries are optional, and that's one of the reasons why it does not always work if you perform a reverse lookup. Because if there is no entry, well, there's something missing in the tree. So it should provide information about the mapping of addresses to names. And these are then exactly the entries I have to make in the database, that I say, okay, my computer, 192.249.249.1 has the following name, wormhole.add so on. So that's the idea. So if someone searches for the real computer behind this address, for example, preventing from spoofing, spam, whatever, then in the end, my database, my primary master, should give the authoritative answer, this is wormhole. That's the unique name. And then I can check if someone claims to be wormhole, plus the reverse lookup tells me this is wormhole, then okay. There's no 100% guarantee, but that's a good sign. The problem is that if you do not make these entries, and they are optional, then there will be no answer. And if you do not trust all the computers giving you no answer here, well, this is a problem. Then you cannot trust many of the computers. So, but that's one of the ideas why having these pointer records in your primary master responsible, in this case, for movie edu, whatever university this is, movie university. What else? Mail exchanger, that's also quite often used. So Amex records, they are needed for email, because if I want to send, for example, an email to whatever, to me, so then it's schiller@computer.org. Okay, I've got an email program, but who is this? Who is this? Is this a computer, whatever? No, I have to contact as email program. In the end, we will see how this works. The mailer, the mail program, the mail server for computer.org. And this, in the end, has to boil down to a whatever it is IP address. So that's not the IP address, but that's just an example. So how do I find this out? This is why I need the Amex records. So basically, there is an email server responsible for a certain domain. In this case, computer.org from IEEE. So I have to be able to contact this. So now we need a certain entry telling us, okay, here who is responsible for certain domain, computer.org, etc. as the mail server. And this entry tells us, okay, there is someone responsible. Here, that's the mail server for whatever, with a certain preference. Preferences, these are not no absolute value, but you could have some more entries here with some more servers, and first you contact this one, and if this doesn't work, you contact the next one, etc. Relative preference is important, and first you address the mail server with the smallest value. So as I said, you can find a lot more information about this in literature, but this gives you a good impression of how this DNS system works. So what happens in the real world? Let's have a quick glimpse. So if we check for the requests, DNS requests, and check the name length, it's quite interesting to see the majority in the internet of requests in on x-axis you see characters is something between, I would say, 12 and something like 40 characters. So 12 to 40 characters. So we typically do not go to these 255 whatever long characters. And just to compare, it's interesting to see here in the IoT world, the peak is around 25 here, as you see. So that's just shows you, okay, so that's just my example of the lengths. And it's also interesting to see what type of requests we have. So what are the queried records? So queried records are in the normal internet. You see the vast majority is IP version 4. So almost two-thirds is IP version 4. And almost 20% is IP version 6. IP version 6, well, the standard is from 1996. Yeah, it takes a while. And then there are others like name server, etc. Some reverse lookups, and some others. So there's something going on. And on the IoT world, just for comparison, it's quite interesting to see that we also have IP version 4, version 6, etc. We have a lot more of these pointer records queried here, almost 20%. And this comes together with something we'll have a closer look later, multicast. We cannot go into all the details. There's a multicast DNS that is used for zero configuration of devices. That's just to show you that you get a rough feeling of the distribution of the different types of queries. Okay, so some questions. Why do we need the resource records? What can we store there? What is this resource record? And what is the minimum entry we have in the resource records? What do we need at least? And what is the majority asking for? Okay, it fits, yes, no? What else can be stored there? So you can find this out in the literature. And then just think of yourself, how can you find out the mail server of your university? How does this work? I will give you the tools at the end.